Okay, we're back taking a look at examples of solving quadratic equations using roots, and here are a couple more examples. And these are a little bit more complicated. It's not obvious how to take a square root right away. If we take a look at this left example, if we solve for x squared, then unfortunately we'd still have an x term floating around there, so we could not simply take a square root. But maybe we can apply a couple techniques together. For example, you may recognize this as a perfect square trinomial. That is, 4x squared gives you this term, 5 squared gives you this term, and you'll notice that this is negative 2 times 4 times 5, which means this is a perfect square trinomial. Please review the factoring sections. And essentially what I'm going to do is factor this, and right away call it 4x minus 5 squared, and that's equal to 0. Now, you would use the square root property if you had factored. In this case, we can take a square root, but either way works. And just verify for yourself that that is indeed equal to the above expression on the left side of the equation. But to use this idea of taking square roots, I've called this something squared. So now all I've got to do is take a square root of both sides. Okay. Square root of this binomial, that's squared, equals the square root of 0, and we put the plus and the minus. The square root of this guy squared is just 4x minus 5, equals plus and minus. The square root of 0 is 0. Now, of course, positive 0 and negative 0 are the same number, so I could simply say 4x minus 5 is equal to 0, and continue to solve the equation. So from here, let's add 5 to both sides, add 5. That gets me to 4x is equal to 5. Divide both sides by 4. And x is equal to 5 over 4 is our solution. And technically, this is a repeated solution. So we can say that this has multiplicity 2, for example. But graphically, it just looks like one point where this graph crosses the x-axis, and it's right there at 5/4. So let's take a look at the other equation. And I point this one out because I have a number on the right side of the equation. This one you may recognize as a perfect square trinomial once again. If we were trying to factor this and solve by factoring, then we would have to subtract that 36 from both sides so that we had a 0 on one side. But I'm going to try a different technique, again recognizing that this is a perfect square trinomial. So we're going to call it the perfect square that it is. Namely, this is 2x plus 3 squared. And if you'd like, multiply that out just to verify that 2x plus 3 squared does produce 4x squared plus 12x plus 9. So this is equal to 36. Okay, and this time I'm just going to leave a little space to begin with, because in my next step, as you've seen, we're always doing the same thing. We're taking a square root. So there's my square root of this side. Here's the square root of this side, and don't forget to apply your plus and minus. So on the left, I end up with 2x plus 3 is equal to plus and minus. The square root of 36 is exactly 6. At this point, I will subtract 3 from both sides, which gives me 2x equal to, I like to put this term first, so negative 3 plus or minus 6, and then divide both sides by 2, and I put the bar under everything. You can do it under each term, or you can put it under everything. These two fellows cancel, and we have x equals negative 3 plus or minus 6 all over 2. And then at this point, I like to separate it into the two solutions that this represents. One of them is negative 3 plus 6, all of that divided by 2. The other one is negative 3 minus 6, all of that divided by 2. Negative 3 plus 6 is 3 over 2, and so this is one of our solutions. Negative 3 minus 6 is negative 9 over 2. And there is another solution. And indeed, if you were to check this out, the way you would do it is you would take one of those solutions, take them one at a time, take one of these solutions and plug it into x into the original equation. And in this case, if it equals 36, then you know you got a correct solution. So I encourage you to check each one of those with the original equation and make sure that the left side does indeed equal the right side when you plug those values in, again, one at a time. Okay, let's continue toward a little bit more complex examples.